好，这个很欢迎啊，大家来参加这一场是由我们服务科学学会跟中山大学资讯管理系一起合办的这个演讲。那我是服务科学学会的这个理事长啊，那我们的这个一起合办的这个单位中山资管的系主任徐世杰在这个地方。好，这场演讲真的是很难得了因为主要是我们前几天办那个国际的研讨会是服务科学还有服务创新的这个国际研讨会。那研讨会里面呢，因为我们想促进大家在服务科学方面的跨国的合作所以要求日本的服务科学学会的理事长，就今天的这个讲者然后也有邀请了马来西亚服务科学学会这个理事长那我们今天这个讲者Masaaki Mochimaru 这中文名字呢叫持丸正明，可能会大家比较容易记忆点那他不只是那个服务科学日本服务科学学会这个理事长事实上呢，他在日本的 AISD 一个单位，大概就是类似台湾的工研院、国比工研还要大然后做的事情更多那他在 AISD 待了相当长的这个一段时间历任过好几个单位的这个 director那最近的这个单位的这个是叫做人类增强研究中心，就是有那个 Human Augmentation Human Augmentation 的那个 Research Center 这个director那同时呢，他在那个Servitization 方面因为在服务里面我们讲说制造业要服务化那其他领域看起来本来不是提供服务的这样的这个一个东西呢很多东西都变成这个服务化，所以他在这方面也做了很多那我接下来介绍一下他的这个经历那Dr. Masaaki Sensei 他是1993年获得庆应大学的博士那同年呢加入工商省产业科学技术厅生物技术产业研究所。那2001年呢出任国立研究开发法人产业技术研究刚讲的 AIST 那他的数位人体研究室的这个副主任然后2010年呢兼任这个中心的这个主任。那2015年呢就担任 AIST 人类资讯研究部的部长。那2018年就是他现在的这个现职就是 AIST 里面的人体增强研究中心的这个主任那这个中心呢专门研究人体工学然后生物力学从事这个人体工学跟行为测量、建模还有工业应用这个研究那Dr. Masaaki 的那个研究呢，发表在生物力学、人体工学、资讯学还有服务科学这个领域。那这个著作本身目前发表超过200篇的这个论文。那有多篇论文在国际研讨会获得最佳这个论文奖那他获得奖项呢，包括日本经济产业部长奖、AIST 的这个院长奖、庆应大学的杰出校友奖等。那他也担任过北海道科州大学、竹坡大学、东京都立大学的这个客座教授。那而且很重要的一点他也长期担任相关的那个 ISO 的这个标准的这个建立那他目前呢是 ISO PC 329，叫做 Consumer Incident Investigation Guideline 所以应该是跟那个这个consumer 这个服务或者 service failure 相关的这个标准这个定的这个主席所以可以说经验非常的丰富那他今天的讲题呢是 Human Augmentation Researches for the Low Birth Rate Society. I think this is related to his research and originally the title of the talk is about Servitization, but we just asked Professor Masaaki. Actually, this work is also related about Servitization. So let's welcome Dr. Masaaki.
Thank you very much, and thank you for having the opportunity to So I'm sorry, I changed my title, but don't worry, this topic includes servitization. Okay, so now I am the director of the Human Augmentation Research Center. It's a very rare word for you. What is human augmentation? So augmentation is, how to say, to enhance, to expand something. So human augmentation is, this is a human self, and human with information technology or robot technology. So through this kind of technology, human function is augmented by the system support temporarily. That is one part of the human augmentation. But we also focusing on using those kind of human augmentation technologies. Our biological system itself can be augmented. So it's not temporary, it's permanently augmented. So what is human augmentation with is like a partner or wearable. Finally, the transparent means transparent to all the cognition. So it's how to say, no attention to using the system. So my research background is human factors engineering or ergonomics. So this is in the ergonomics field, human function can be divided into 4 categories. One is the physical function, motion, so the second, sensation, and eye or ear, so the third is the cognition in the brain, or is the communication with other persons. So human augmentation starts from the measuring technology. So how to measure the human function? It's lots of items, but we also try to develop a new measurement device. It's a flexible and stretchable device using the printing technologies that well attached to the human itself. And secondly is this dark color circle indicates that each function, each human function was enhanced by the technology, such as just only the physical empowerment and adaptive technology to enhance the eye or ear. So one idea is what we did is wear robotics to avoid fall for the elderly person. So it is how to say, soft robots suit, it is called. Hard robot suit is an exoskeleton. Do you know the HAL, HAL, developed by Sankai sensei in the Tsukuba University? Like how to say, it's a hard shell, it's suited on the leg or something. It's a soft robotic suit, not so powerful, but we measure the muscle activities and timely to help their muscle activities. That is a soft robotic suit. This is a brain machine interface. Not so sophisticated, you might understand. So, my brain did this work. So, using the several EEG from the brain, and special EEG is obtained after the attention. So, his EEG system can detect that signal. And there is a special display on it. So, each option can be seen here and randomly lumped these 8 options. So one is standing, one is drinking, one is eating. So when this person wants to drink something, when the drink icon blinking, they pay attention to the drink icon. The key is these special EEG can be observed. And special EEG is known 300 milliseconds after the attention. So the system checks the 300 milliseconds before what icon was blinked. So that is the system understood, he'd like to drink. Then the icon was changed, tea or coffee or milk or something. Then he likes to T. So when the T blink and he concentrate to the icon. So as a case he detected it. It's a very simple brain bus interface we developed. This is this part, light color part is using the cyberspace metaverse. We connect it to the cyberspace and we can beyond the space or beyond the time or something. So this is just a remote manipulation in a construction machine. I will talk about later. And this is another application is teleworking. So hybrid teleworking. Today we are in person, and if we get that in person or in the online both, in that case online person will sit there. That is a hybrid teleworking system. Okay, so I'd like to introduce some research activities of our research center. So this is, as I told you, flexible and stretchable devices. It is not based on silicon. It is based on organic system. So just only these kind of special ink is used. So it is just a blending silk screen or inkjet system and blending this pattern with this ink. And put a little bit high temperature, 150 degrees Celsius. This kind of special chemical ink can be changed to be detected strain. It's a strain gauges, and it's a much more sensitive one than metal strain gauges, and stretchable or flexible. This is another sensor. Is pressure distribution sensor, also flexible. So one application of this stretchable or strain gauges, it is named e-mask. This is an icon of the university. So University of Tokyo. So we are here. We are not university, National Institute. So our institute built a building in the campus of the University of Tokyo, not in Tokyo, Kashiwa is next to the Tokyo. Anyway, so we are in the campus of the University of Tokyo, so we have the class of the laboratory of the in the our research center of the University of Tokyo. This is the research on graduate students from the University of Tokyo. We, I said, get a student from the University of Tokyo. So his work is silent speech interaction. Silent speech interaction is no voice, but just only the movement of the mouse. So computer system detected what was talked by the human without voice. So usually use a camera to get the motion of the mouse, but his idea is to use face masks. So in this face mask, a lot of strain gauges was pointed out, and after that, it is using the AI, very rough work. So he developed this equipment, and he asked the subject to wear it. And this is a command of the to control the Alexa speakers. So 21 control, and he asked 21 words to say to the subject and to recruit, for example, 10 or 20 subjects. And using the convolutional neural network, detected strain patterns, and these words are connected by machine learning. Over 99% it can be detected. So very easy. But anyway, so it is a new interface without voices. So if you try to use a ChatGPT and your computer can be controlled by your voice, but your voice can be here to the thing next to you. It's a much more severe issue in the security. So in this idea is to speak without voice, just only the movement of the mouth. And it is a new interfaces, potential new interfaces. It's another application with the same sensor. So this sensor was like a band put here and to detect muscle activities. Usually muscle activity detected by EMG, electromyograms. But in some cases, it is a little bit troublesome during the daily activity measurement. This is a very simple idea, such as during the muscle activation, little bit volumetric changes, deformation can be detected by the sensors. It's an daily use. I'd like to introduce one application that industry. So, as I told you, our laboratory is located in Kashiwa, is the name of the region. So, this region is a little bit special region. So, our main department, AIST's main department, is located in Tsukuba, another location. It's a little bit far from Tokyo Central, maybe 1 hour or 1.5 hour drive from central Tokyo. So around 10 years ago, new train was developed from the central Tokyo to Tsukuba. So at that time, the Kashiwa is between them. So before then, Kashiwa has a forest and golf course, and just only a small campus of the Chiba University and another campus of the Tokyo University. So the golf course was owned by one big real estate company. They stopped the golf course. They rebuilt the town at the golf course, and a very tall building, a residential building, and shopping malls and hotels. So this is a newly developed area. We use this town, and the real estate company asked us that every year we have a special event in the fall, Innovation Festival. At the Innovation Festival, we provide our technology for the citizens in this region. This is 2 years ago we did. So it is a little bit difficult to understand. We, at that time, the real estate company contacted with some special production to keep the intellectual property of the heroes. Lots of animation heroes and science fiction heroes in Japan. So this is one of the heroes. Due to the IP issue, I cannot say the exact name of the hero. Anyway, big hero, okay? And this is a monster. That is in that TV program. So the story is the monster is attacking the Kashiwa town, okay? And we recruited 30 participants for this program. Of course, a very heavy competitive selection process. He is one of them. And we asked the participants to keep the ropes and to stop the monster, or very heavy task. So, and we put muscle sensors to him and 4 sensors at the ropes. Okay, first stage. We asked him to keep the rope and stop the monster. This is a monster, and we measure the force of the rope. It's a 6 kilogram force at that time. Okay, with this story, everyone failed the first step. Oh, your force is not enough to stop the monster. Yes, I know, of course. So we will move to the second phase. He wears a special vest. This is that we developed with artificial muscles. Artificial muscle is to use special vacuum system and to, make a force. And we asked him something like a story. Okay, you fell, but don't worry. You wear the special suits developed by a Kashiwa Center scientist. We put on your vest. Please use it and try it. So he tried. Fortunately, he used an artificial muscle well. His pulling force is a little bit increased. Of course, at that time, we measured the net or muscle force is not same. Okay, so increasing is due to this artificial muscle. In this story, the second phase is failed. So, unfortunately, you failed. You cannot stop the monster. So, we provide him special eyeglass. It's to metamorphose to the human, to the ultra hero. Okay, so he wears a mask, and at the cage screen is changed to the superhero, and he moves. Then the motion capture gets his motion, and superhero also the same motion. Agent, it is agency. He understands. Oh, I can be the superhero. We ask him, okay, one more try. 13. Interestingly, his force is remarkably increased. It is called Porter's effect. In a virtual space, your agent, your avatar, changes the structure or posture with you. So your behavior was affected from the virtual avatar. In this case, he changed to the ultra hero, and he said, "Oh, I'm the hero." At the case, he could make much more muscle forces. So at the case, a total is 13, and we put the muscle force here is also increased at that time. Anyway, it is one entertainment example, but it is human augmentation. It's a physically human augmentation. It's a psychological human augmentation. Okay, so our institute, our research center, we have 40 research scientists, and including the student, staff, in total over 100 members that work at our institute. One is sensing devices, as I told you, and virtual reality, augmented reality, robotics, and biomechanics is my expertise, and psychological and cognitive science, and service engineering and design. So those are focusing on human augmentation, and application in one is care service to take care of the elderly, and second is health service. So to keep the good health for the mid-aged person. And the third is working to gain the work skills and to improve the work engagement. That is means of our laboratory. I have two examples. This is a care service with remote rehabilitation. So I'm sorry, some of it is Japanese, but I hope you can see Chinese character. Anyway, this is rehabilitation. This is a physical service here, and this is not patient. Patient is here in the home. This is Glow is the hospital, Green is the home. So this is a robot. So orange wear is a specialty wear we designed, multimodal or wear, and this orange wear detected his motion and sent it to the robot. So both wearing the goggle, so he gets an image of the patient overlapped on the robot. So the physical therapist understood, oh, my patient is here, and okay, you were jointed a little bit tight and much more movement like this. So he did those kind of rehabilitation aid. So no robot here. So of course, it is better to use a robot in the home, but it is difficult to be the sustainable business. So this robot can be used by any other participants. Whole day, this robot can be worked. In contrast, here is a robot, but for example, 30 minutes or 1 hour per day, and other hours are not active, and it is a little bit expensive. Maintenance is required, so it's not so good idea to use a robot in the home. So our idea is to use tactile sensation or something. So robot can detect the touch area of the hand of the physical surface. Then this region was a little bit higher temperature, a little bit vibration, and with computer graphics of the physical surface. So interestingly, this human understood, oh, physical surface is really located here. He touching my hand here, and they get rehabilitation in the reality. That is the idea. So we developed this is not correct way, but this is a special way. So we put a lot of flexible sensor, same as a mask, and through these sensor we detect three-dimensional motion of a patient and send it to the robot in the hospital. And it is done by remote rehabilitation. Why remote rehabilitation? It is due to the declining the birth rate. So we are facing to the issue of the declining the birth rate. So working population is decreasing in Japan. So population decreasing in total Japan, but it's depend on the local or rural area. Tokyo or Osaka is not so severe problem. So local area has one subfield can be much more bigger. So it is difficult to visit the hospital. So it's too far. So one solution is those kind of rural or local area, and rehabilitation can be get service through the new real technologies. This is another service research related to the construction company, construction machine company. So Komatsu is a famous company with a construction machine like this. So they are very famous in servitization. They already installed a lot of sensors to the construction machine. They monitor the situation of the old construction machines in the world through the satellite communication. So of course the main purpose is remote maintenance or predictive forecasting maintenance and so on. Of course it's a very well worked for the Komatsu business. This is the next stage of the, it is called contracts. This is the next stage of contracts. So in present, their servitization business is focusing on monitoring the behavior of construction machine. And this second stage of servitization is monitoring not only construction machine but also employees. It's his. So to enhance employee satisfaction or employees' work engagement, or to reduce employees' fatigue, or to improve the employees' work skill. That is the solution. Future how you say, population is decreasing, not so many buildings are required to be developed. But our land is same size. We have to keep the maintenance. So we have a lot of work to maintain the building and bridges and tunnels and so on. So we should keep the number of workers for the construction field. So we try to have the skill up employees and to enhance the work engagement. That is a big project with Komatsu company. And we have to say provide our research on the virtual reality or sensing, digital human modeling and psychology and service engineering part here. And in the total integration, we provide a solution to the Komatsu. One, actually, this is a physical part. The other is how to say, remote control of the construction machine. That's a case employee how to say, put in the virtual space, cyberspace, and controls the construction machine through the virtual reality. So this is much more effective to enhance the skill. This is because we can present any additional sign to the display. So we try to check what kind of additional display is good for the skill enhancement. It is interesting to me. So it's in a directory display for the control is much more important. So this is a servitization. So we, like Komatsu is one example, we collaborated with much more manufacturing company in service research. So this is because here in Taiwan and of course in Japan, lots of big manufacturing companies like Toyota, Nissan is a motor company, and any other Hitachi is any other machinery company. So they are strongly interested in shifting the service. For example, mobility as a service, MaaS. So not selling the car itself, but selling the function of the car is a mobility. It's a servitization. So lots of manufacturing company interested in to shift the service business. So actually there is several obstacles. How to deal with the obstacles, and we propose first stages. We told them where you are and where you want to go. So this is the servitization stage. The first stage or second stage is, how you say, or for example, it's a service that leads a product to sales or service that maintain the customer's relationship. It's how you say, viewpoint is to promote the product itself. So such as I told you, for maintenance or preventive maintenance or remote service or installation or instruction, those are including these service stages. Most of manufacturing company already did this servitization, and they are still located here. But it is not actual servitization. Actual servitization is the green stage. Third stage is service that improve the value of the customer use of the product. And fourth stage is service that leads the customer's innovation. So not for the service for selling the product, not for service for the as they continue the use our product. We try to solve the customer's pain. That is the real servitization. So, for example, the Komatsu in present they are located here. Contracts is remote maintenance or preventive maintenance. It is in the second stage. But finally, they try to change their customers and work engagement. So productivity, that is the fourth stage. Their innovation. they are focusing on from the second stage to the fourth stage using the human augmentation technologies. Anyway, so we are providing this kind of idea with the marketing researchers. She is Keiko Toya, is a major university social scientist, and she provides mainly service management. What should be done in the management, and we provide service engineering. What should we help by the engineering? So that is the servitization process. So this is how to say, Komatsu of the medium-term management plan. It's of course developed by Komatsu, not with us. So in this case, they are focusing on the products and solution and services. So in this case, the services in the service dominant logic, it is the service, it is the services, and it's the goods. So goods and the services and combined to the solution, it is the final solution, the service. Anyway, they don't know the service dominant logic, but they will done to design mid-term management plan. So we took this management plan and we proposed our research activity. And through the research, we provide our original design method. It's a participatory design. So as a case, we should recruit users in the employees of not Komatsu, but a construction company involved in the project, and we design these kind of services with not only Komatsu but also customers. That is the general design process, the product and service simultaneously. Okay, so this is a framework of our research center. So start from the sensing, wearable sensing, and digital human modeling in cyberspace. From the sense data, we can estimate fatigue or work engagement or something. Then we try to make an intervention to the customer using the virtual reality or robotics technology and so on. Then human function can be enhanced. This kind of the blue technology itself is human augmentation technology. We are not a university. We are belonging to the Ministry of Industry. So our focus is not only development of the fundamental technology, but also launching a new business related to human augmentation. So as I told you, mobility as a service. I am the director. I started this research center. At that time, I think human augmentation should be studied as a service, not selling the suits, but selling the experiment of the entertainment or productivity enhancement for the customer. That is the point of the sale. So we recruited the service engineering member to our research center and how to design the value, co-creation value to the customer and with these technologies. And one more is we recruited also the design research member, not limited to the services. So this is because in some cases, not how to say design systems should be designed is not limited to the provider and users, but for the communities or any other stakeholders. That's the case, it is an ecosystem should be also designed. So our institute has, as I told you, 100 members, and 2,000 are related to these technologies. This is called our technology institute. But 1/3 are related to the social engineering, service design, co-creative design, data ontology, customer satisfaction. So they are both, all members contributed in research projects, for example, in Komatsu project. So I move on to the metaverse. So we also use the metaverse. Of course, in the commerce case, we use the virtual reality. And this is another application using virtual reality for the, this is the restaurant, Royal Host, a Japanese family restaurant. We collaborated with them. So they try to train the new employees. Actually, they have one training restaurant. Restaurant for training, not for all business. So usually, new employee visits a training restaurant, and the skilled employee and or something like an local the participant joins that restaurant and to train with the scenario. That is an original training system. So this is under the COVID-19. It was difficult to join together to the same location. So we made a training restaurant in the virtual space. And he is an AI agent, not human operating agent. And training is a new employee with via Google enter to this virtual reality training restaurant. And the trainer is a skilled employee. So one kid simultaneously enter to the virtual space. And the other option is after the training, she can check the training process with lots of viewpoints and set a comment to the training. What's the why? So we started this project. And this is a viewpoint of the training. So, of course, Royal Host is a nice family restaurant. That's just a family restaurant. It's how to say, of course, hospitality is important, but not so waiting for the customer is much more important. So it's easy, but this scenario makes a new customer to the entrance, so that how to say, employee can detect the new customer quickly and to deal with the new customer or something. So anyway, that is a training system. And after developing this system, we of course apply to the Royal Host itself. At that time, the employee said, "Oh, it's good, but it is better to train with a real restaurant." Not a training restaurant, but a real restaurant that I will work. Oh, that's good. So we developed the editors. So Royal Host has lots of branches. So every branches has a different facilitation. So editor can change the location of the table or the walls, and AI agent automatically behave based on the table or a kitchen space. And they can train a restaurant that they will work. It is now used in real service. Okay, so that is the location of my research center. It's in Tsukuba, as I told you. This is Tokyo, and this is my building of my research center. It's in Kashiwaka town. So. Service is not be completely designed in the laboratory. It should be tested in a real field. So we take this town itself as a laboratory. It is called social laboratory. So not so many population. It is 2,000 population in this small area, 2 kilometers square. So very tall residential building and offices and hotels and shopping malls. As I told you, it is a real estate company developed newly. So anyway, so citizens and government, local government and company, we recruited company, and we are here in a research institute or university, and we have some infrastructure. So it is Japanese, it's humans, and this is the methodologies. and this is the field. So we prepare this kind of infrastructure, and we try service design, as I told you, with citizens. So development for the future vision with citizens. We have a special team from the leading citizens. So it is Japanese. All members study or everyone study is meaning is like so. Anyway, so someone interested in to contribute our research, easy to join our research work and something like workshops, and we provide something to them. For example, so what do we want to be when they become elderly? They say like this, and so on. And our design researcher facilitate this kind of workshop. And in some cases, this is virtually make an experiment and in a virtual customer space, and it is something like a living lab. So in that case, we also provide our design methodologies, not limited in service. It's in participatory design, digital and physical, and social. It's a triangle, and there is a service concept and future vision agreed with participants. And those kind of through the collaborative design, and the company implements something like a sample system, and to provide it to the social lab. And we check the acceptability for the citizens and profitability for the company and so on. So it is our laboratory, social lab. Okay, and I'd like to talk about one more topic related to the virtual world. It is my job, but not our institute. It's I am the program director of the governmental research funds. It's an SIP, Cross Ministerial Strategic Innovation Promotion Program, very well named. So last year, the third phase of SIP was studied. At that time, 14 programs was registered. One of them is the development of foundational technology and rules for expanding virtual economy. The virtual economy is a newly developed economy using the metaverse. So I was appointed the program director. I have to manage the total budget and around 1.5 to 2.0 billion year by year, little bit. So concept is interverse. So this is the universe. This is the virtual space, metaverse. Beta is how to say, another or hyper or something. So I'm focusing on the interverse, not only visit the metaverse and create a co-creation value only metaverse, like role-playing game in the metaverse. Is to join here and to create value here, not any return back to the universe. But considering huge promotion, so you visit the metaverse and you have to say train in the metaverse, and your avatar is merely virtual, but you eat a lot and not so much in the real space. It's not so huge promotion. So we return back the value from the metaverse to the interverse. That is the focus of this project. So this is based on our research. And future metaverse market, virtual economy market is $1 trillion and very, very big. Of course, not only Japan, in the world, 2013. So in our forecasting, 30% is based on financial virtual currency. And another 30% related to entertainment and games and so on. And the remaining 40%, it is interverse. connected to the real factory or maintenance and rehabilitation and health. We are focusing on this 40%. So this is a national project. I have to set a strategy to compete with another country. So this is a universe. We have a little bit individual difference, contextual difference, lifestyles. This is a metaverse, and I guess several metaverse can be observed in the future. So US can get the touch point of smartphone, ChatGPT, and they will get the touch point of metaverse. Very, very strong. Okay. It is difficult to compete with them. This is Germany. Germany, several years ago, they shifted Industry 4.0. Industry 4.0 is focusing on not revenue, but revenue. They are difficult to get a touch point on daily living or daily working. They are focusing on factory. They have a big company, Siemens and SAP. They have 40% of the touch point of this field. So they said it is an Industry 4.0. Where is our Japanese solution? So I'm focusing on these a little bit area. So it's similar to your country. So we have sales company, home appliance company, the cars and production goods on lots of detailed goods to contact with those detailed information. So in that case, one bad story is they get lots of data, detailed working or live activities, and send it to them. That's just only sensing company. So our idea is those kinds of detailed information can be created new services. It is called the interval service. So it's a touch detailed information, not for the general information. It's strongly connected to the field or individual differences and so on. So of course, scale is much bigger. Yes, much bigger. But we are not, selling the sensors. But of course, we have services. And we have one stakeholder and to discuss with them. That is my strategy to establish this program. So we already accepted several proposals. 9 projects was accepted in this proposal. So this is an application field. So manufacturing, office service, and science, health, sports, education. And this is a little bit of regional health and social capital, small city, smart city, and so on. So red color indicates an accepted project, mainly university, and this is a construction company, this is a startup company, this is the big infrastructure company. Okay. And we also interested in an interface that is extend value for interface. And this is a platform software, and this is a legislation of the standardization and LC or social acceptance. And we also interested in human resource development for the new business field. This is a framework. So, universe, metaverse, and databases, interverse technologies are fundamental, and this is a foundational data exchange platform, and software development kit, APIs, and human resource development and standardization. So, I quickly introduce you the project we accepted. One is an H2L. Is a very, very small venture company. They have a good technology to provide proprioceptive information. So proprioceptive information is, our human can sense my body or weight through the muscles and so on. So their technology can make a special intervention to the muscles and to feel the how to say weight or pose in the virtual space. So it is their technology. They how to say establish their technology and to apply to the office work or tourism or remote interaction and so on. That is here, this project. This is my colleague proposed. So this is the how to say hybrid work. Virtually enter the office and real workers in the office, but combined in the metaverse office and to promote the productivity of the office. And this is a little bit change. It is a 3D printer of the food. So it's a sushi was made by 3D printer. So virtual space, they design a sushi and of course the colors and taste and completely represented in the real world. It's one of the metaverse. But of course it's a little bit expensive than the actual sushi. What is an advantage of this 3D printer? It's a softness is completely controlled. So elderly person want to eat sushi, but in some cases he's difficult to eat those kind of hard material. So in that case, same looks and the same taste, but very soft. It's utilized to those kind of healthcare stuff and so on. This is another application. And this is Nagoya University. Their idea is remote work. So in the maintenance field or factory, working at robot, yes, simple robot. And workers everywhere in Japan enter the control the robot very short time works. And for example, I am today staying home, but I have now time 3 hours. I can work with a factory 100 kilometers far away, and with Google and smartphones, and I can earn money from the short-term job. It is the final goal of this how to say network, they say. This Takenaka is general constructors. They have research on to enhance the happiness of the citizens. They already did it is in the real world, real town, like not in Kashiwaka, but in Shibuya or several another place. But it is difficult to change the trial in the real town. It is a very time-consuming and cost-effective. So they try to use the virtual space. They develop the virtual Shibuya. A lot of citizens in real places visiting here, and happiness is major in the virtual space. So for example, one building or any other facilitation can be designed in the virtual space, and then check the effectiveness and try to do real construction. That is the idea of the Takenaka Corporation. And one is NTT Docomo is their company on the cell phone. So they are developing a human augmentation platform. So lots of devices is proposed for the human augmentation. So easier, it is easy to connect with simple software interfaces. They are developing a software development kit for those kind of devices. Of course, some devices are newly developed in our project. They try to develop those kind of software development kit. It is to reduce an obstacle to enter this business or the study. So finally, we try to human resource development and very good international standardization. I try to get standard or to promote intercourse business. That is our project. Okay. So finally, I conclude my presentation. Sorry, a little bit longer. So this is the trend of the working age population. Now we are here. So our population is reducing, and but big population still remaining in the elderly, and working age is remarkably decreasing. So we have to deal with this issue. So some jobs will not decrease in a low birth rate society. Population will be reduced. So that case, restaurant or transportation service, everything is reduced. So required worker can be reduced. No problem. I don't think so. Medical nursing care services, as case elderly person still remaining and working population is decreasing, it's a serious issue. As I told you, national land conservation and maintenance services. Our national health area not be reduced. Just on the population reduced. We have to maintain the building and the bridges and the tunnels and so on. So it is still required workers. So and one more, export-oriented manufacturing industry. So you have a lot of this kind of industry. So you have say manufacture lots of semiconductors not be used in the domestic, used in worldwide. As a case that if your population can be reduced, but the worldwide market is not being reduced, you should provide lots of semiconductors. Similar with the cars or bikes. Japanese population reduced and domestic sales can be reduced, but the international sales not be reduced. As a case, we need lots of workers in here. Mobility services. To ride and to use mobility is reduced due to the population reduced, but long transportation can be required for the sparse society, so it cannot be reduced. So how to deal with it? What is an acceptable foreign labor force? We get lots of immigration from another country, but it is very difficult. This is because your country, any other Asian country, and same situation, and they become aging and so on. So automation using AI and robots. Of course, we are trying. Full automation, everything by AI, everything by robots. But I think several another solution required. That is the human and AI, human and robots. That is human augmentation. Human operators still remain, improving labor productivity through human augmentation, such as AI robots, reducing the physical movement by utilizing the metals. That's to deal with mobility issues. Anyway, that is the situation of our research, and that is service research and contribution through the human augmentation. Thank you for your attention.
Thank you, Dr. Masaaki, for the wonderful presentation and show us many interesting projects done by his team or AISD. And he also covered not only the IT artifact, but also the service, the system, even to the economy, especially the virtual economy. Very interesting talk.
Thank you.
Okay, any questions from the audience? Yes.
At this one point, I can quite understand about the job equation, and we talk about the mobility service.
Yeah.
I thought maybe in the future all the vehicle can be self-driven.
I hope so. I hope so. But
in that case, So
Yeah.
the job won't decrease.
Yeah, I think so. But yeah, I guess you agree with my idea. So for US, it is easy, and for mainland China, that can be easy to change to the full automatic driving. But here in Taiwan or also Japan, very narrow corridor or something, and with lots of pedestrians. Actually, it is difficult to realize that full automation mobility and so. So, depending on these duration, we have to solve the mobility issue. But in future, we can change to the full automation.
Okay. Thank you. And one more question.
Yeah.
So for the augmented human.
Yeah.
For augmented human technology.
Yeah.
I can easily think about the health or care issue for maybe elder person or disabled people.
Yeah.
But in your presentation, this part is not very addressed or be emphasized. And I'm curious about how is the Japan policy toward the accessibility issues, and is there any government policy trying to enforce, the well-being of the elderly people or disabled people?
Yes. Thank you. Yes, sure. So not only human augmentation, but all digital technology, we are facing to the accessibility issues, especially in the elderly person hesitate to use all those kind of new technologies or difficult to use those kind of technologies. So in our cases, actually, it is difficult to apply to the elderly person directly. But for example, the care service, augmented human is carer, not a patient. So in that case, employees with human augmentation technology take care service much more efficiently. So that is our approach, and then those kind of employees will be get aged and change to the elderly. At that time, they can accept to use human augmentation technology directly. In present, we try to apply to workers or a middle-aged person. That is the starting point.
Okay, got it. Thank you very much.
Okay, any further questions?
So professors, so basically, you focus on the productivity instead of just like the audience you mentioned, the disabled people or handicapped people.
Yeah.
Okay. Yeah, and actually, I was doing several research projects which is related to the metaverse. Okay, and for aged people, and we also face some problem. I mean, the aged people, they just don't want to use it. Okay,
Yeah.
and the goggle, it's almost impossible to put it on. Okay, for more than 30 minutes. Okay. So we eventually gave it up. Okay, so we, instead of applying it to the aged people, we applied it to the people who provide care. Okay, and so now we trying to apply it to the area. For example, for the aged people who has mental problem, and their family member have to take care of them. And so we are creating the scenario and in the training process, and to help those family member, they may show some strange behavior, and how should you react to that kind of behavior? Yeah, and so it's not a question, but it's more like a feedback.
Yeah, thank you. Yes, that's very, very good idea. So actually, we have not so big project, but a small example. We applied virtual reality technology to elderly person directly. As a case, one application is as you told you, change their how to say psychological behavior, and the next is using the Prometheus effect. I told you using the superhero. It's using physical training. So interestingly, with an goal is required. So elderly person keeps the dumbbell, but a very lightweight dumbbell. Heavyweight dumbbell is due to the disorder, the musculoskeletal system. But in contrast, the lightweight dumbbell is not so effective to the muscles. So interestingly, to wear the goggle and to keep the very, very heavy dumbbell in the virtual space. The actual space is very lightweight. So as a case, muscle activation pattern is remarkably changed. Very effective is lightweight, but good for the muscles, but also good for the joint. It is one small solution be accepted for the elderly person. So as a case, our how to say participants over 70 or over 65, they accepted to use Google. But very short time, just only 5 minutes or so. Oh, that is a reason why they accepted virtual reality. Thank you very much for your time.
Okay, any more questions? I have a question. It's more high-level question. We know that virtual economy was very hot a couple of years ago, including I remember 2 years ago when Professor Xu was hosting ICSI 2022. At that time, the topic was metaverse something. Okay, metaverse service science. But 2 years ago, the emergence of generative AI, these days it seems that people's focus as well as the investment have been heavily moved to GAI. So I'd like to seek your opinions about the future of virtual economy.
Okay, so to see the market size, it's much smaller than the GAI. Unfortunately, generative AI makes it is expected a very, very much bigger market. But how do you say it? So this is a national project. So national government, of course, they provide generative AI and any other AI's research. But, for example, the U.S. Big company is a very big fund. So it's very different from the national research budget. They get very, very big money. They have lots of GPIs than all GPIs in Japan. So, as a case, if the Japanese government provide a small amount of money means comparing with an OpenAI. So, is it effective for get the market for the generative AI? That is a concern of government. So they of course provide quantum technologies or AI of course, but they also try to this kind of a field. Hopefully it will be get some share size of the market in the world. So that is a strategy, I think.
Okay, thank you. And actually, that's also my personal feeling. I think metaverse or even the interverse you have mentioned will come someday. It may not be in the next 2 or 3 years, but eventually it will come. And with the help of GAI, the result, the service could be even better. So that's something we can expect, I think, in the future. Okay, any more questions?
I ask a question on top of your question? Okay, actually, I went to telecom company just like NTT Docomo, it's a Zhonghua Telecom in Taiwan. Okay, and they are thinking about to build, whether they should invest on generative AI and to develop an ecosystem. Because even though it has been very popular in the past 1-2 years, but they didn't see the exact, profitable business model. Okay, and so since we're talking about servitization, yeah, this kind of things, and so and eventually you say that building an ecosystem may be required, and so from your perspective, generative AI. So how should if you were the consultant, what kind of suggestion you provide to our NTT Docomo in Taiwan? Say that how to build an ecosystem? Should they invest? Should they build that? And what role they should play? Yeah. That's a very big question.
Yeah, okay. But in my sense, so Taiwan is an industrial situation is close to Japan. So for example, so European country gave up to keep the home appliance technology. Or Siemens for 20 years ago, they developed a refrigerator, but they gave up to keep those kind of business. GE is also. So anyway, they changed the business and much more structured than B2B. Of course, for example, we have a lot of electric company and Panasonic or Toshiba. They can change following up to the Siemens or GE. That's one strategy, as I told you. But we think, this video. I visited Fraunhofer Institute, and Wolfgang is my friend. I visited him, and I heard him. What is Industry 4.0? That was his answer. So not nominal representation. His answer is Industry 4.0 is focusing on Siemens and such. It is to keep the touch point comparing with China and US. That is only one solution for Germany. That is his answer. So at that time, he said to me, so why? I know why you visited to me. So you have a lot of company like Siemens, and you get an attack from Korea and China. They gave up to keep the several items. So you try to hear how to deal with in Germany. Welcome to our world. That's his answer. But I get one idea from his advices. So they mean that the US and the European company evacuated from those kind of field 20 years ago. 20 years ago. There's no IoT, no AI. With AI, with IoT, we are still keeping this kind of industry. That is the difference. So we are very severe business on a manufacturing company, but as a case, we are keeping on the touch point of the detail of the lifestyle or working situation and so on. So as a case, we can get detailed data not obtained from the smartphone. Smartphone cannot get all data, just only the general data. Much more specific data can be observed our products. So the production company in Taiwan or in Japan can get the data much more strategically and to move the service with that data. That is my idea.
Okay. Thank you.
Okay, thank you. No more questions? Further questions? Okay. Originally we planned this talk only for 40 minutes, but we ended up take about 1 hour and a half. Thank Dr. Masaaki Sensei very much for giving us so much information and the discussion from the audience was good. I think that those who could not make it to this talk must regret it. Okay, let's give Dr. Masaaki Sensei another applause.
Because there are many organizations and consultant here, so maybe
Okay, maybe we can take a picture together.